Hi, for question number 7 from October 2010, A-Level Maths HSC Paper 3. The times spent by people visiting a certain dentist are independent and normally distributed with a mean of 8.2 minutes. 79% of people who visit this dentist have visits lasting less than 10 minutes. For the first part, find the standard deviation of the time spent by people visiting this dentist. For the second part, find the probability that the time spent visiting this dentist by a randomly chosen person deviates from the mean by more than 1 minute. And for the third part, find the probability that of 6 randomly chosen people, more than 2 have visits lasting longer than 10 minutes. For the fourth part, finally, find the probability that of 35 randomly chosen people, fewer than 16 have visits lasting less than 8.2 minutes. Okay, for the first part of the question, we are told that x is normally distributed with mean 8.2 and standard deviation sigma square. So also p of x being less than 10 is given as 0.79. Therefore, what do we make of that? We can standardize this by saying that p of z is going to be less than 10 minus 8.2 and all divided by the standard deviation, and that's going to give us 0.79. Therefore 10 minus 8 is 1.8 over the standard deviation is going to give us inverse I of 0.79. Therefore 1.8 over the standard deviation is going to give us what is 0.79? The inverse I of, if you check this out from your table, you're going to end up with 0.807. Therefore the standard deviation is going to be 1.8 divided by 0.807, and that's going to give you 2.23 to 3 significant figures. Okay, and so here we are for the first part. Now for the second part, we are told that remember, the mean is 8.2. We're told that it's deviating 1 minute above the mean, 1 minute more than the mean. So this is the time spent by a person, alright, visiting the dentist, deviates from the mean by more than 1 minute. Therefore we are looking at probability of the mod of z being greater than a. Alright, and what is that? Basically it's 1 minus the probability of the mod of z being less than a. And if you check this from your textbook, you will find out that this is 1 minus what is probability of z being mod of z being less than a? It is 2 phi of a, okay, minus 1. Therefore if you do a little calculation here, a little bit of algebra, 1 minus minus 1 is 2 minus 2 phi of a, which basically if you factorize is 1 minus phi of a, where a is the standardized value. So what is a? Basically we have, it's deviating from by more than 1 minute, so 9.2 if you add 1 minute here minus 8.2 over the standard deviation. So the standard deviation is 2.23, and let's do that. That's going to be 9.2 minus 8 is 1 divided by 2.23. It's going to give us 0.4484. Therefore 2 times 1 minus 5 of 0.4484, and let's do it in our calculator. So inverse, we look at the phi value, it's going to give us this much. Okay, so 1 minus the answer is going to give us this much, and then times 2, so 0.65384, so 0.654 to 3 significant figures. Here we are. Second part of the question is done. Moving on to the third part, we are told in the third part that six randomly chosen people are chosen, and then more than 2 have visits lasting longer than 10 minutes. So n is equal to 6, and their visit is longer than 10 minutes. Probability of x being greater than 10 minutes is going to give us 0.21, because less was 0.79. So this is our probability of success. P is equal to 0.21 and Q is going to be equal to 0.79. Therefore, we're looking at what we want, more than 2 people. So probability of x being greater than 2 is going to be exactly the same as 1 minus probability of x being 0, 1 and 2. So we have then 1 minus, it's a binomial distribution here, and 6c0 times 0.21, a probability of success to the power of 0 times 0.79 probability of failure to the power of 6. So plus 6c1 0.21 times 0.79 to the power of 5 plus 6c3 0.21 to the power of so this is 0.c2 to the square times 0.79 to the power of 4. So we have 1 minus, let's compute that. If you do this on your calculator, you're going to end up with 0.243087 plus this one is going to be 0.3837 and so on, and this one's going to be 0.257654 and so on. So we are looking at 1 minus the sum of all of that, which is 0.88844 and so on. So your answer should then be 0.112 to 3 significant figures. Third part of the question is done. Now for the fourth part. For the fourth part, let me just draw your attention to the normal distribution curve. Our mean is here, 8.2. So greater than 8.2 is this area here, and less than 8.2 is this area here, 0.5, 0.5. So we have a probability of success, probability of failure as well. There's 35 randomly chosen people this time, so n is equal to 35. So where can we go? Now this is quite large, and we can clearly see that if we take 35 times 0.5, so NP is going to be 35 times 0.5. Also we got NQ is equal to 35 times 0.5. Both of them is going to give us 17.5, meaning that since NP and NQ are both greater than 5, therefore x is approximately distributed to a normal distribution with mean 17.5, and the variance is going to be NPQ, 35 times 0.5 times 0.5. Work that out, you're going to come up to 8.75. Therefore, from here we need to find the probability that x is going to be less than 16, that is fewer than 16 people, their visit's going to last less than 8.2 minutes. So we can do this because it's we've approximated to a normal distribution, we have to carry out the continuity correction. So after continuity correction, where do we go? We're going to come up with probability of z being less than 15.5 minus the mean. The mean is 17.5 divided by the standard deviation, which is the square root of 8.75. Now let's work that out from our calculator. It's going to be equal to z being less than minus 0.676. So what is this basically? We're looking at here minus a, so that's going to be reflected on the other side. Sorry for the graph like this. So that's going to become the probability of x being less than 16 is then 1 minus p of z being less than 0.676. So we're looking at 1 minus the phi of 0.676. So 1 minus phi of 0.676 is going to give us 0.24952. So 0.24952. Therefore we can conclude that it's going to be 0.250 to 3 significant figures. So here we are for this question taken from October October 2010, A-Level Maths HSC S1.